All right, so we are up to 1G. There is only 2 more sections after this. We're going to be summing the geometric series. So there's 2 formulas for this as well, but the 2 formulas are for different values of R. If R is bigger than 1, meaning that the terms in your sequence are getting bigger, then you need to use this top formula. See how it says absolute value because negative, it's okay for it to be about -5 is still going to use that top formula. So the absolute value of whatever R is, if it's bigger than 1, then we're going to use this top formula here. If it is less than 1, but it's really -1 to 1, okay, then we're going to use the second formula down here.
Right. Sounds good.
Right. Okay.
So basically, if it's a decimal, it's above.
If it's anything, yeah, any fraction or decimal, yes, correct. We'll talk later, Mr. Ben. All right. Questions. Number 1. Find the sum of the first 10 terms of a geometric series with the first term 3 and the common ratio 4. So let's write down on the side here, the first term, which is A, is 3. The ratio is equal to 4. And it says I want the sum of the first 10 terms, so that means n is going to be equal to 10. Because I am summing, looking at my formulas up here, my R is 4, which means I'm using the top formula. Okay, so using that top formula, I'll write it down. It's S of n equals A bracket R to the power of n minus 1 over R take away 1. So just subbing in, this is just straightforward, this question. Sum of 10 terms equals A is 3, R is 4, N is 10. Okay, and then just calculator. It's quite a big number. It should be 1,048,575. Okay, straightforward. Not going to get any easier than that. So next question. Find the sum to 8 terms of the series 8, 16, 8 and 4, ... So I want 8 terms. N is equal to 8. I know the first term is 16. And I need to know R, get that from my series. Remember that you take the second term and divide it by the first term. So 8 divided by 16 is a half. So R is going to be equal to a half, or 0.5. Which means my R is less than 1. So I'm going to use the second formula. So that's now just a substitution problem. So A, second formula is 1 minus R to the N over 1 minus R. The formulas are very similar. The only thing that you need to remember is whether the R to the N is, or the R is before the 1 or after the 1. If R is less than 1, the R is second. You can think of it, you want to keep your fraction positive, so the R will be in the second position. But if R is bigger than 1, it'll be in the first spot. So let's sub in 8 bracket 1 minus a half to the power of 8.
Isn't it 16 bracket?
Oh yeah, thanks. 16 over 1 minus a half equals, what do we get? 31.87. Is that what you said? Yeah, is that right? Or 875, so I should write that to an 88 then. All right, question 3. How many terms of the series 2 plus 6 plus 18 plus ... are needed to give a sum of 728? So here's where we start doing things a little bit differently. We're trying to find something else in the formula. We're trying to find the n, the number of terms. So A is the 2, R is, if I do 6 divided by 2 is 3. I don't know the N, that's what I'm trying to find, but I do know the sum of my terms. I want it to be 728. Because R is greater than 1, we use our top formula, S to the N equals A, R to the N take away 1, over R take away 1. Subbing in the sum on the left-hand side, 728 equals A is 2, R is 3 to the power of N, take away 1, over 3 take away 1, which is going to be 2 on the bottom there. So I need to rearrange it. First of all, the 2 on the denominator times it across to the other side. So that's 1, 4, 5, 6 equals, actually I could have just cancelled, that would have been easier, wouldn't it? Alright, let's do that now. Divide the 2 away and I get back to my 728. Then add the 1 across to the other side. 3 to the N equals 729. And if we want to do this without logarithms, we would be trying to find 729 as a base of 3. It can be done because it is a term of the series, so it will be a nice whole number.
6.
Yeah, good. 3 to the power of 6. So if the bases are the same, that means that N is equal to 6, and that's what I was after, the number of terms. So 6 terms in that series would have a sum of 728. That's what that means. All right, next one. Question 4, we have a sigma in here. I want to sum from the 4th term to the 9th term of 3 to the N. Now, if you're given a question like this on the test, it's not going to tell you that this is a geometric question. It could be an arithmetic. You would probably want to work out the first few terms just to be sure you know what type of series you're dealing with here. So let's do that. Subbing in from the lowest number, we're actually starting with a 4. It will be 3 to the power of 4 plus the next term would be 3 to the power of 5 plus 3 to the power of 6 plus, and we would keep going, and it would actually go all the way to 3 to the power of N. I mean, you could find every single one of those terms there because there's not very many of them and add them together. We did that in our first lesson on summing. But since we are practicing with our new formula, let's do it with our formula as well. Those terms would be 3 to the power of 4 is 81, and 243, 729, plus dot, 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 dot. Okay, and the last one is 19683. So if that is my series, I've got A is equal to 81, R is equal to, what do you think? 3. N is equal to, how many terms do I have?
6.
Oh, good. So you're doing the 9 take away 4 plus 1, plus 1. You do 9 take away 4 plus 1, which is 6 terms in that series. And because R is greater than 1, we use the formula which has the R to the N first in the bracket. And sub in. A is 81. R is 3 to the power of 6. Take away 1 over 3 take away 1. And we type it in. 29,484. Good. Okay, but as I said, you could have probably done that one faster just by working out the terms for that one. Question 5. Evaluate 80 plus 10 plus 5 over 4 plus dot, 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 plus the last term is going to be 5 over 16,384. A, I know is 80. What is R? 1/8, good. N is what I don't know. I don't know that. But I do know the last term. So I'm going to call that T of N is equal to 5 over 16,384. To sum that series, I need to know N. So I'm going to have to use my term formula to find out the N. The term formula, hopefully you remember, for a geometric is AR to the power of n minus 1. So the last term is 5 out of 16,384. A is 80. R is 1/8 to the power of n take away 1. Okay, getting the n by itself. We have to divide that 80 across to the other side. That will make a very small number, fraction, 262,144. Now, that 1/8 to the power of n minus 1, I could expand the bracket out. 1 to the power of any power is going to be 1, so it really would just be 8 to the power of n minus 1 on the bottom. By doing that, it means I can get rid of those fractions. I can just invert both sides, and I have 8 to the power of n minus 1 is equal to that big number on the denominator on the left. Okay, I can then go fishing. If I don't want to do logs, you can always resort to logs if you need to, but you can then go fishing for a number with a base 8 that is equal to that 262,144. It is 6, good. So 8 to the power of 6. So that means the powers must be equal. N minus 1 is going to be equal to 6, which means that n is equal to 7. That was not what I needed for the question though, or the answer. It's not the answer. Because the answer was to find the sum. I'm trying to sum. It says evaluate. I want to add my series up. So I want to sum my series. R is a fraction this time, so I need to have the version which is the 1 first in the bracket. So A bracket 1 minus R to the n over 1 minus R. And then I can just sub into that. A is 80. 1 minus R is 1/8 to the power of n, which I worked out was 7. That needs to be divided by 1 minus 1/8. And I'm kind of doing this quickly, but typing that in could actually, be careful. There is things that you need to put in brackets in there. Did anyone do it?
91.
Not yet? Yeah, good. 91.43. That's to 2 decimal places. That's it.